Hello, my name's Craig Barton and welcome to this Tips for Teachers video. Now, for much of my teaching career, my focus has been on teacher-generated examples. Some of you may be familiar with my work on my variationtheory.com website, where I put a lot of time into trying to create sequences of related examples so students can attend to the critical differences between them and notice key things about mathematical structure and so on. However, and I'm quite ashamed to admit this, only relatively recently have I become aware and a massive advocate of the power of learner-generated examples. Now, for me, in mathematics anyway, the seminal work on this is the wonderful Thinkers publication by the ATM. Now, within Thinkers, there are lots of structures for helping students come up with learner-generated examples. In this video, I'm going to focus on the two that I think are the most powerful because of their versatility. I think you can pretty much use these for any idea in mathematics. And I wonder if you're a teacher of another subject, whether these same structures can be applied to help students generate examples within your area. Okay, now the way we're going to run this is you're going to be my students and I'm going to be the teacher. So you can generate your examples as we go through this. And as we go, I'll touch upon a few key elements of pedagogy, but at the end, once we've gone through the two structures, I'll just point out 4 key features that I think are important to help this run as smoothly as possible. Okay, so here's the first structure. It's called Give Me an Example of, and another, and another. And it works like this. Right, on a piece of paper, what I would like you to do is give me an example of a fraction that's equivalent to 2/3. Write that down for me, please. Now, you might want to pause the video if I go too fast or you're getting annoyed or something like that. Right, have you got that one? Okay, on that same piece of paper, what I would like you to do, please, is write me another fraction that is equivalent to 2/3. Okay? And finally, on that same piece of paper, you know what's coming, right? Give me another. Now, once you've got your 3 fractions, and as I say, feel free to pause if I'm going too fast here, I'd like you to do one more thing, please. And that is just spend a few moments thinking about how you constructed those 3 examples. And here are 3 prompts to help you. So how did you come up with your first example? What was your technique there? Did that technique change when you came up with your second and third examples? And did this process get easier or harder as you came up with your 3 examples? Just spend a few moments just contemplating that and pause the video. Okay, now let's jump into the classroom, how I would run this. So I do exactly the same as I've done with you there. The only difference being, as I'll talk about a little later, is students will be writing this on mini whiteboards. At the end of this process, once the students had independently come up with 3 fractions and then spent a few moments considering how they constructed their examples, I would ask them to hold their mini whiteboards up all at the same time so I could see the spread of ideas that they've come up with. Then what I'd ask students to do is to discuss their examples with the person next to them. First, show each other their 3 examples and see if they've got any the same or any different. But then what I'm particularly interested in is them describing their process for constructing their examples. And by prompting them to do this independently first before the discussion, I really think it helps make that discussion much more positive and much more productive. And then, of course, what I can then do once students have had this discussion is, having seen the range of examples that are out there, I can then instigate a whole class discussion. So I can say, Miriam, I see your first one you came up with was 4/6. How did you come up with 4/6 for that first one? Michael, but you didn't do 4/6. You did 40/30, 40/60ths or whatever it may be. And then I can just use what I've seen when I've seen all the whiteboards to pick out particularly interesting or quirky examples, and we can discuss it. Of course, the thing I've forgotten to mention is that when students are having this initial paired discussion, they can, of course, check each other's examples so they get additional practice of fraction equivalence or simplification and so on and so forth. Now, what you may have noticed is, as you're challenged to come up with another and another, perhaps you start doing a slightly different way of thinking. Perhaps everyone has this first obvious fraction that comes to mind when they do 2/3. Maybe it is 4/6. But then as you're asked to come up with another and another, then maybe you start to think slightly differently. Some students may just keep doubling. double the numerator and denominator, then double it again. But within a class of 25, 30 students, you're bound to find some different approaches, and that's going to really add fuel to the whole class discussion that you can have. Okay, so that's the first structure. The second one is called additional constraints. Now, I think this is a little bit more challenging, both in terms of challenging to write as a teacher, but also more challenging for the students. So should we give this one a go? All right, here we go. So we're still on fractions, but a slightly different skill this time. So I would like you to think of a pair of fractions that add to 1. And again, can you write that down? Any two fractions that add to 1. Again, you might want to pause the video at this point, just so you have a bit of time. All right. Once you've got that, now I want you to think of a pair of fractions that add to 1, but also have different denominators. And once you've got that, and as I say, keep pausing me here, now I want a pair of fractions that add to 1, have different denominators, and have the same numerator. And then when you've got that one, I want them to add to 1, have different denominators and the same numerator, and one fraction's got to be improper. And once you've come up with those, I want you to think about how you constructed your examples. Okay, so again, feel free to pause the video until you've had an opportunity to think through those yourself, but now I just want to jump into the pedagogy of how I would run this. This would be one where, again on mini whiteboards, but this time I would ask the students to show me their examples at each stage of the process. In the previous structure, it was the students wrote all 3 down before they showed. Here I want to see it as we go through. That's really important because as this gets more complex, I just want to pick up just in case there's any misconceptions happening in the class. But also, I want students' attention focusing on each of the challenges I've asked them to do at that moment in time. So let's say, for example, there was a really interesting answer that I saw for this second prompt. Well, if I'm only seeing that after students have thought about all 4 prompts, it's quite hard to bring their attention back to that second prompt. So what I like to do is give the students time to do this on their own. So think of fractions that add to 1. Time to think about how they constructed their example, and then I want to see everybody's, and then I can then go into the crowd and say, oh, how did you come up with that? How did you come up with that? And so on. And then we move on to this second constraint. So this, as I say, is a little bit more difficult to write because you've got to kind of, I spent ages doing this one. And I came up with about 3 or 4 impossible ones, which again would have been an interesting twist, but perhaps not ideal. And maybe these are more difficult for students to answer, but I think this is a super useful structure. So I mentioned just a few kind of pedagogical points that I wanted to make. And the first is I think mini whiteboards are essential for this. They're essential for a number of reasons. It's really important that I, as a teacher, can see students' answers, and for me, a mini whiteboard is a really powerful way for doing that. It means I can pick up on any misunderstandings, but also I can then clearly see really interesting answers that I want to use in the whole class discussion. It's also really good for the students as well. We know students like to kind of rub off things, and they're less likely, I think, to fear making mistakes if it's kind of rub-offable, if that's even a word. But I also think it works well in the paired discussion. It's much easier, I think, to swap a mini whiteboard with your partner than it is to go through the hassle of swapping books and then, and so on and so forth. I just think it's a lot easier kind of practically for students to work together to have peer discussions with mini whiteboards. That leads into the second thing. Really great this for peer assessment and peer discussion. Peer assessment in terms of checking each other's answers, that's a really important part of this. But also peer discussion, and because students have been working on the same task but may well, and I think it's quite likely this, have come up with different answers, they can have some really good discussions about their answers, particularly if they've been prompted to consider already how they came up with their examples. Final 2, again, I won't use these all the time, but you may find these useful. You could say to students, maybe in that, give me an example and another. It could be, give me an example. Then the second one could be, give me an easy example. Then the third one could be, give me a hard example. And it just adds an extra little twist, maybe an extra little constraint in there that perhaps gets the students, particularly if you're finding they're just kind of doubling numerator and doubling the denominator each time, maybe that prompts them just to think a little bit differently. It's one of those that's worth experimenting with. Likewise, I really like this, give me interesting examples. So again, you could use that in the give me an example of and another and another. The last one could be give me an interesting example. And I find it really fascinating to see what students find interesting, and that can be a really worthwhile discussion. Or you can use it throughout those additional constraints. You could say to students, okay, if you found an example really quickly, I want you to come up with a second example, but make it as interesting as possible. So in the additional constraints one, it's not just give me two fractions that add to 1, it's give me two fractions that add to 1, and then give me an interesting pair of fractions that add to 1, and so on and so forth. So anyway, they are two of my favourite structures for learner-generated examples. What do you think of those? Have you used those before? Do you use those slightly differently to I do? If you teach a subject other than maths, could you make use of those in your subject? I'd be fascinated to hear how you do that. If you found this in any way useful, I'd be so grateful if you could like this video and subscribe to the Tips for Teachers YouTube channel. And if you want to visit tipsforteachers.co.uk, you'll find loads more tips like this, not just from me. Thanks so much for watching.